Hi, I'm Paddy Shannon. I'm the Technical Director at SST Sensing. Today I was just going to do a quick demonstration of our optical liquid level sensors and just to show you how versatile they are. Now traditionally, when you want to measure or detect liquid, and that's what these sensors do, they detect whether a sensor is in air or in liquid. The traditional technology is a float switch. Now float switches are quite large, they're typically about this kind of size. They have to protrude into the area where you want to measure the liquid, and they've got moving parts, and of course having moving parts is always an issue because that's something to wear out or to get jammed or get broken, or maybe it might freeze and they might stick in place. Our optical liquid level sensors are typically very small. Here's one here, and it's attached to a tester which will buzz, and the LED will illuminate when it's wet. And you can see that this is one of our smallest sensors. This little bit here, just the cone, this is the actual sensing tip. What's happening inside is we've got infrared LED and an infrared phototransistor, and the light from the infrared LED comes out, bounces around the face of the inside face of the cone and back to the detector when the sensor's in air. And that's because the difference in the refractive index between the plastic, which the housing is made of, and the outside, this atmosphere around here. But when we stick it into liquid, and it's really any liquid, a lot of that light escapes. We see a smaller signal coming back to the detector, and the microprocessor inside the sensor then looks at that and says, well, I must now be in liquid, and it changes the output state accordingly. So we're going to test it here in, first of all, water. You can see that worked. And then we've got, the next one is vegetable oil. Also works. Then we've got some antifreeze. Then we've got brake fluid. And finally, this is one we're very pleased with, is we can detect milk. Now, traditionally detecting milk's difficult because it's a reflective material, it's a reflective liquid. I'm just going to clean that tip and get rid of the rubbish. Milk is a reflective liquid, and the problem with milk typically with this type of optical sensor is that when the light escapes into the milk, it then bounces off all the fat particles, comes back in, and the sensor thinks it's in air again. But with some clever software that we've developed for this sensor, it can actually reliably detect milk. So that's it, very simple. The sensors are very versatile, as you could see there, and I'll demonstrate that again. They only have to detect in a tiny amount of liquid to make the sensor actually actuate. Unlike a float switch, which would have to actually lift from maybe here to here, which would require quite a large amount of liquid. So they're great for detecting really small liquid leaks, for example, into cabinets. We sell a lot of sensors into telecoms cabinets, where we're detecting the instant that any rainwater gets into the cabinet, so someone can go and fix it before damage occurs to the inside electronics. So they also operate from -40 Celsius up to 140 Celsius. All sorts of shapes and sizes, different cable lengths. We do different connector styles, different materials which are suitable for different chemicals, including glass tips, which are obviously extremely robust and can handle virtually any liquid and very corrosive acids. So that's it. SST's liquid level range of sensors. Very versatile, very reliable.